Welcome back, chemistry fans. Today, what we're going to try and accomplish is the multiple choice portion of the Unit 4 exam. So we're going to jump right into it, share my screen, and we are going to work on some of these problems as they pop up. Here we go. So question number 1, it says, well, what is a beta particle? And so you had to know alpha particles are a helium nucleus. Beta particles are just simply electrons. If we were to go to number 2, thorium-234 decays by alpha fission. That means it breaks apart. So we have thorium and 234 is its number. So we come down here and we see that thorium is element 90. It's going to break apart into a 4,2 alpha plus something else. So we do the math up top. That means 230, because 230 and 4 gives me 234. 88 down below plus 2 would give me the 90 value that's on the left. If I look what that is, it is radium. So now this also is going to help us when we get to our multiple choice. So I'm looking for 230 radium down there. All right. So when we do our free response, this is also going to be something that will help us get to some answers if we knew how to deal with alpha fission as part of the detail there. All right. So which of the following gas contains the most molecules? So what we would have to do is divide these by their weights off of the periodic table, and I add those weights up already. 55 divided by 44 is 1.25 moles. 3 divided by 2 is 1.5 moles. 34 divided by 34 is 1 mole. And 14 divided by 28 is half of a mole. Therefore, the 3 grams of H2 is the most number of moles or molecules, the same thing. Okay, how many grams of 0.332 moles are there of this material? So if I add up my weight of this compound, 137 for the barium, there are 2 chlorines, whoops, and it's a sum. Some of you were wondering, do I multiply it? It's 2 times 35.5 for the chlorines and 6 times the weight of the oxygen. So 137 plus 71 plus the weight of all those oxygens, 16 times 6. And that gives you 304. So we got to go and find the answer that's closest to that. And 322, where did I get that from? Let's see if I've screwed something up. Oh, times 0.332. That's what I did. So my answer, whenever I multiply it, because in the mole map, moles to grams means that I'm going to multiply. And so my answer comes out to be 101, roughly. All right, now it makes sense. Let's go to question number 5. So in question number 5, we are doing grams to molecules. And so we have to know again what the weight of salt is. It weighs 58. So I'm going to go grams to moles. That is 945 divided by 58 gives me 16.3 moles. But then I'm going to multiply that by Avogadro's number. And what you get is 9.8 times 10 to the 24th molecules. So let's see what that comes out to be as the closest answer. Oh, it's right down here, 9.73. Okay, now moving on. What type of radiation causes an increase in atomic number? Well, if I have an alpha particle, 4,2, and I add it to some other material, let's just say it was 30 and 60. Sorry, other way around, 60 and 30. Well, if I add an alpha particle, it's going to make it into 64 and 32. So an alpha particle needs to be added to it. That only happens when you have fusion. All right. And you're saying, well, what about a beta particle? Well, a beta particle is 0, -1. So if I were to subtract 1, that would actually lower the atomic number. All right. So which of the following depicts a nuclear decay? It's the one that goes down first off, and the only one that does go down is A and D, but D goes at this positive arc, and it needs to be this exponential decay down here. that has the concave arc to it. All right, question number 8. It's the one that I threw out. So you had to know that there is a nuclear power plant that has this cycle of not me. It goes through nuclear reactions, which heat up water, turning it into steam, which is thermal energy. And that powers a mechanical device called a turbine, which then spins inside of a magnet, which gives us electrical energy. All right, so those would be the steps, not me, going in order that were matched up with the answers on that question number 8. All right, so now here comes our half-life question, our first one. So we should do a time versus amount. Time always starts at 0. It says in this one that the amount is 4.68. It says the half-life is 1.5 days, and you keep doing this until you hit 6 days. Well, if we add these together, there's 3, there's 6. So what I've got to do is take my 4.68 and divide it by 2 each time. And I get 1.17 divided by 2. I get 0.585 divided by 2, and you get 0.29. All right. So finding the answer that matches that, and that is the 0.293. Okay, so moving on to question number 10. I just did that one. Oh boy, I must have put it on here twice. Sorry about that one. So on number 10, what type of radiation is in the correct order of penetrating power? Gamma radiation is made up of light. That was your little bonus hint there. So which one causes the most penetration from lowest to highest? It's this first choice, alpha, beta, gamma. So it goes from biggest particles down to smallest, and the smallest particles are the ones that cause the most penetration and the most deadly damage. And you could have seen that whenever we get to the next question. One of the next questions has the electromagnetic spectrum. You could have used that one to help you get your answer. Okay, so in this question, number 11, what we're doing is another half-life, and it's asking how long is the half-life? Well, we start at time, we end with amount. Time always starts at 0, and it says that it took 36 hours for this to decay. So we don't know how long that is, but we do know that it's used up 86 material, has decayed. So if I am at 100, or we could reword this and say there's only 12.5 left. Well, that occurs after the third half-life. So if it took 36 hours for this to occur, there are 3 half-lives. My answer is 12 hours is how long it took. How many moles are in 24.5 liters? It doesn't matter what this material is. We're going from liters down at the bottom into moles, and that's a division process. We will divide by 22.4. 24.5 divided by 22.4 gives me 1.1 or 1.09. So let's see where we are. That's that bottom answer down there. Okay, moving onward. Question number 13. We're almost done with the multiple choice here. Here's that electromagnetic spectrum. Which is the most dangerous? It's over here where the particles are the smallest. Gamma radiation is the most dangerous, which echoes with the previous question I had talked about, which is the most penetrating. That would be the gamma radiation. Okay, so now we are on to the fill in the blanks. So I will stop my video here for the multiple choice. Talk to you soon. Thank you very much. Goodbye.